Okay, so for FRQ number 1, we have a projectile that is initially 35 meters above ground level on top of a cliff, and we are going to launch this projectile at a velocity of 50 meters per second and at an angle of 37 degrees off a cliff. Once the projectile finishes its flight after launch, it's going to land a distance of r away from its initial position, and it will be at ground level at point C. In the diagram, we are given different points of the flight, A, B, and C, and we are also told in this problem to use 10 meters per second squared for G, 0.6 for sine of 37, and 0.8 for cosine of 37. Okay, so part A wants us to calculate the total time from launch until the projectile hits the ground at point C. So before starting the problem, I'm going to first figure out my x and y component of my initial velocity, so that way I can just plug them in my problems later instead of having to find it each time. Okay, so here's my initial velocity. It was 50 meters per second, and it was angled at 37 degrees. This is my theta, this is my VI. And so I want to find my x and y components of my VIY. So this is my VIX and this is my VIY. So since the angle was given relative to the horizontal, my VIX is going to be equal to VI times cosine of theta. And that means once I plug in my numbers, it's going to be equal to 50 meters per second times cosine of 37 degrees. And I was told to use 0.8 for cosine of 37 degrees, so it's just going to be equal to 50 times 0.8, and this is going to be equal to 40 meters per second. My VIY is going to be equal to VI sine of theta. So this is going to be equal to 50 meters per second times sine of 37 degrees instead. And for sine of 37, I was told to use 0.6. So this is going to be equal to 50 times 0.6. And plugging this into the calculator, we're going to get 30 meters per second. Okay, so I've used I found my x and y component for my initial velocity. Now I'm going to start on the problem. So part A, once again, we were told to calculate the total time from launch until the projectile hits the ground at point C. So to do this, I'm going to use this kinematic equation, but in the vertical direction. So delta y is going to be equal to VIY times time plus 1/2 times AY times t squared. Okay, so I'm going to plug in my numbers now. My delta y, at point C, I've gone down 35 meters, so my delta y is going to be negative 35 meters. My VIY I found up here to be 30 meters per second, so 30 meters per second. Time is what I'm trying to figure out. Plus 1/2. My AY is equal to negative G. And for G, I was told to use 10 meters per second. So this is going to be equal to negative 10 meters per second squared. Or negative 10 meters per second squared, I meant. And times t squared. Okay. So I'm going to add 35 to this side to make it look like a polynomial where I can use the quadratic formula. So 0 is equal to, now I'm going to put this in descending degree order. So this is going to come first because it has a t squared. So this reduces down to -5t squared. This is 35t, and adding this over, I have 35 over here. So now that I have it in this form, I can use my quadratic formula. Now when I use my quadratic formula, I'm going to choose the positive answer because there's two answers. And that means my t is going to equal to 7 seconds. Okay, that's part A. Now part B wants me to calculate the horizontal distance r that the projectile travels before hitting the ground. So basically this whole thing. Okay, so since I found the total time of flight, this is quite easy. I'm going to use a similar I'm going to use the similar kinematic equation, but in the x direction. So delta x is equal to Vix times t plus 1/2 ax times t squared. Okay, so now I'm going to plug in my numbers. My delta x in this case is r, what I'm trying to find. My Vix I found to be 40 meters per second up here. 40 meters per second. My time is what I found up here, and that is 7 seconds. This whole term cancels out because my acceleration in the horizontal direction is 0 meters per second squared. So this is basically what my r is equal, and plugging this into the calculator, I'm going to get 280 meters. So that is the distance of r. Okay. Now for part C, we are told to calculate the speed of the projectile at points A, B, and C. So at the peak, at a point where the height is the same as the initial, and at the end of the flight. Okay. So starting at point A, so as I said before, point A is the peak, and I know that at the peak, my Vy is going to be 0, so that means my Vy at point A is 0. So that means that my velocity or my speed at point A is equal to my the x component at that point. So Vax, my Vx doesn't change, so my Vax is going to be equal to my Vix, and I know my Vx is 40 meters per second, so that is going to be my answer for Va. Okay, now for point B, I'm going to use conservation of energy. So that means PE, potential energy initial, plus KE initial is going to be equal to my potential energy at point B plus my KE at point B. My potential energy initial is M times G times H initial. My KEI is 1/2 times M times VI squared. My potential energy at point B is M times G times H at point B. My KEB is 1/2 times M times, that's an M, times V at point B squared. Okay. Now, as I said before, the height is the same at both these points. So that means my HI is equal to my HB. Now in this equation, or in this problem, my M and G are constant. So that means that my PEI is equal to my PEB. So that means in this problem, I can cancel them out. So this cancels out. So I'm left with 1/2 mvi squared is equal to 1/2 mvb squared. Once again, I can cancel out 1/2 m and the squared. So that means my VB, my velocity at point B, or my speed at point B, is equal to my VI, which is 50 meters per second. 50 meters per second right here. Okay. Now point C. Point C, once again, I'm going to use conservation of energy. So PEI plus KEI is going to be equal to my PE at point C plus KE at point C. Once again, PEI is mg times h initial plus KEI is 1/2 m times VI squared. Potential energy at point C is m times g times h at point C. KE at point C is 1/2 m times v at point C squared. Okay, so at this point I can cancel out all my m's, and so I'm left with this. Okay, so at this point I can just plug in my numbers since I have everything. G, I was told to use 10 meters per second squared. HI is 35 meters. VI was 50 meters per second and squared. That's going to be equal to G is 10 meters per second squared. H at point C, the height was ground level, so this is going to be 0 meters. Plus 1/2 VC squared. VC is what we're trying to find. Okay, so this whole thing over here reduces down to 1,600. This term cancels out because it's multiplied by 0, and this just stays the same. So 1/2 VC squared. To solve for VC, I'm going to times 2 and then square root everything. So VC is equal to 1,600 times 2 and then square root that. And plugging this in the calculator, I'm going to get 56.569 meters per second as my speed at point C. And we're done.